Hello algebra students, and welcome back to another video lesson as we continue on with chapter 12, where we've been working a lot on factoring, solving even the discriminant. Today we're going to work on identifying zeros of a factored polynomial. So they've already done the work for us, it's already factored. And then can we write equations in factored form if we already have the x-intercepts? Can we go backwards? So to start out, I do want to remind you, we have a Chapter 12 test number 2 coming up on Tuesday, May 4th. That's next week, Tuesday, where the topics here are factoring. Basically, can you simplify? Can you then solve by factoring? Can you find the discriminant, which will tell us if the quadratic is factorable? And then polynomial functions and working with them. That's the info that's going to be coming today. Here's two warm-ups that I'd like you to try on your own. Why don't you pause the video and try these two? Number one, simplify. So when we're simplifying, it's almost like solving. We should go through our steps, and the first thing is to check for a GCF. In this case, there is a GCF of 2, right? The number 2 would go into all of those. 2, 2, and 2. That'll leave me with x squared minus 6x plus 4. And now I'm going to try and break that down into two things like this, where I get two numbers that multiply up to that 4 value, but at the same time they add up to negative 6. Multiply up to 4, but they add to negative 6. Well, it's either 2 and 2 or 4 and 1. This one is not factorable anymore, right? 2 times 1 is, or 2 times 2, sorry, 2 times 2 is 4, but if I add them, I would get 4. If I had negative 2 and negative 2, that would be negative 4. 4 times 1 is 4, but if I add them, I would get 5 or negative 5. So we could kind of stop there, right? If we went and found that discriminant, it would not be factorable. So the only thing we could take out was the 2, and we would put it out in front of there. The second one, solve x squared minus 24 equals negative 5x. If we're going to solve, our equation does have to equal 0. And so we're going to move the 5x over to say plus 5x minus 24 equals 0. And so we are looking for two numbers that multiply to negative 24, also add up to 5, 8, and 3 make up 24. But I want negative 24. I need one of them to be negative, but they add up to be positive 5. So it would be 8 with negative 3, or x plus 8 times x minus 3. And those are my two factors, okay? So those are the factors. And then we go one more step to solve, and we say x equals negative 8, x equals positive 3 in solving. So that's that solving step. All right. Now, today we're going to get into some polynomials, which tend to have some really kind of crazy, wacky graphs, if you will. All right. We've worked a lot with linear, where they do have one intercept, right? This x minus 1 shows me that x would have to equal 1 as a solution, or it's also the x-intercept. This one actually has 3 x-intercepts. X equals positive 1, x equals negative 2, and x equals positive 4. And if you look at the graph, that certainly is what is happening, right? An intercept at 4, an intercept at 1, and an intercept at negative 2, and the graph just bends and changes directions a couple different times. So these factors, even if we have one factor with the GCF or 3 factors, still help us to identify those x-intercepts, which are the solutions. And that's what this last section is all about, okay? To find x-intercepts, we just need to take each factor and set each factor equal to 0. Each factor. The nice part is that we can ignore the exponents. All those exponents do is make the graph change direction a lot. Okay, so these three problems that are listed down here, even though they look different, and they are different, if we set each factor equal to 0, x minus 1 equals 0, x plus 2 equals 0, x minus 4 equals 0, I solve each one. X equals 1, x equals negative 2, and x equals positive 4. Right? I'm going to take each factor and set it equal to 0, just like we would if we did with 2 factors on our warm-up. Just happens to have 3. Well, if you look at the second one, x minus 1, x plus 2, x minus 4, we don't really need to pay attention to these exponents. We can just take the factor and set it equal to 0 and solve. X equals 1, x equals negative 2, and x equals 4. Same thing's going to happen on the last one. There's just a GCF of 3 that got pulled out front. So we'd still have those same x-intercepts or the same solutions. The graphs would be different, though. So if you ever get polynomials where there's multiple factors, even if there's 4 of them, right? As long as they're all factors being multiplied and the equation equals 0, we can solve each factor by setting it equal to 0. Now the question is, how do we go and solve something like this? Well, again, we can ignore the exponents because it's all being multiplied. And we can say x minus 3 has to equal 0, x plus 2 equals 0, and x plus 10 equals 0. And solve each one. Add 3 to both sides, we get x equals 3. Minus 2 from both sides, and we get x equals negative 2. Subtract 10 from both sides, and we get x equals negative 10. So we solved it for each of those factors in the problem. The challenge becomes, can we work backwards? Can you write an equation for a polynomial who has x-intercepts of 5, negative 6, and 10? So they solved it and they got this. X equals 5, x equals negative 6, and x equals 10. How do we work backwards to show what those factors were so that we could write it as an equation? The goal is to work backwards. Well, if x equals 5 is the answer, that means we had x minus 5 here, right? Because I have to get adding 5 to both sides. Here, if negative 6 is the answer, that means we had x plus 6. And in our last one, if 10 is the answer, well, that means we had x minus 10 to solve it to get x equals 10. And so working backwards is basically just using the opposite of what we have, right? It's that two-way path. X minus 5 solves into x equals 5, x plus 6 solves into x equals negative 6, and x minus 10 solves to x equals 10. Now, how do we write that in standard form? How do we take x minus 5 times x plus 6 times x minus 10 and write it in standard form? We have to use that distributive property. So I'm going to multiply these first two parentheses together. This rainbow method, I think, is what I called it a lot. We've got x squared for these two plus 6x for those two. Negative 5 times x is negative 5x. Negative 5 times 6 is negative 30. Or we end up with x squared plus x minus 30. Now that's just for the first two. We also still have an x minus 10 as a factor on the end. And so now we're going to multiply again, but I'm going to take and distribute this to both pieces, the middle term to both pieces, and the 30 to both pieces, meaning we're going to multiply 6 times, right? X squared times x is x to the third. X squared times negative 10 is negative 10x squared. This x times that x is a positive x squared. The x times negative 10 is negative 10x. The 30 times x is negative 30x. And the negative 30 times negative 10 is plus 300. We have to combine like terms. Now, you could have used a box for this as well. You could have had a 2x3 box if you wanted, where the x and negative 10 maybe were the side with 2, and the x squared with the x and the negative 30 are on the side with 3, and you'd get those same results. We've got to combine like terms. X cubed is by itself. It's the only cubed. Here's an x squared. There's an x squared. And that's it. Negative 10x squared plus and x squared is negative 9x squared. Here's an x, and there's an x. Negative 10, negative 30 gives me negative 40x. Plus 300 is the only one without a variable. It's the only constant, so we leave it as plus 300. And that is in standard form, where we start with x cubed. Okay, so it's a lot of multiplying and a lot of distributing. But the main goal is, can you work backwards to take the answers, those x-intercepts, and turn them into the factors? See if you can't do that with this problem. What is a possible equation, right, in factored form? I don't need you to go to standard. What is a possible equation in factored form? So again, x could equal negative 2. If it has intercepts, x could equal negative 2. X could equal 4. X could equal 3. X could equal 21. And x could equal negative 30. And we're trying to go backwards to show what were the factors to get that. So we could say y equals, if my answer is negative 2, that means I needed x plus 2 as a factor. If my answer is 4, that means I needed x minus 4 as a factor. If an x-intercept is 3, that means I needed x minus 3 as a factor. If I've got x equals 21, that means x minus 21 had to be a factor. And if I've got x equals negative 30, that means x plus 30 needed to be a factor. And that is a possible equation. There'd be a lot to multiply there if you wanted to go to standard form, but we can leave it as a factored form to show that is a possible equation. So that's what we have for our last lesson here as we talk about polynomial functions. Can you really take x-intercepts and turn it into that factored form? If you have any questions, please make sure that you reach out. Otherwise, until next time, everyone, stay safe.